Wake up! What is this? I ask the questions. Now, what is this?
What are you talking about?
You have a chemistry test tomorrow, and we were hired to tutor you. So answer the questions.
That looks like the molecular structure of water. 2 hydrogen atoms bonded with 1 oxygen atom.
Good. Now, tell me, what is the heat of fusion?
Isn't that 79.72 grams per calorie?
She's here.
And joules per gram?
333.55.
Correct. What are hydrogen bonds?
Aren't they just bonds between hydrogen and oxygen?
Well, actually, they're when the negative end of the oxygen is attractive to the positive end of the hydrogen. See how that's a better answer?
Yeah, I see.
Now, we're gonna show you a lab.
Hey kids, it's me, Professor Smartbrain, and today we'll be conducting a lab on the solubility of water. So what we're going to need for this lab is some sugar, baking soda, and Mormon iodized sea salt. Okay, so I measured out 5 grams of salt, and I'm going to pour it into 150 milliliters of water and watch it dissolve. Yeah, watch it dissolve. So if you look really closely, you'll notice that all the salt has dissolved into the water. We're going to do 5 grams of sugar and baking soda and see if they both dissolve. And now you'll notice that both cups, the sugar and baking soda, have dissolved into the water.
Now, why is water the universal solvent?
Because it dissolves more substances than any other liquid?
Is that it? No, it's because of the negative oxygen side and the positive hydrogen side. It's a unique compound, and that's why it bonds with so much stuff.
Now, what is a solute?
Solid. Solute is a solid that dissolves in a liquid, like salt and water. The water would be the solvent, the solute.
Wow, Y chromosome thinks he knows it all, doesn't he now?
Relax. Now, what is the specific heat formula, and how do you calculate for it?
Specific heat. It's the amount of heat per unit mass required to raise the degree by 1 Celsius. I don't know how to calculate for it, though.
Oh, who's the smart guy now? Show him how to do it.
What?
Oh, sorry, that's not right. So, specific heat equals heat added divided by mass times change in temperature.
Got it? You better. It's on the test. So now, what is vapor pressure?
Vapor pressure.
Vapor pressure.
Okay, I might need a second to think. Wait a second. I think I got it. Yeah, I got it. The vapor pressure is the pressure at which water vapor is in thermodynamic equilibrium with its condensed state. At higher pressures, water would condense. The water vapor pressure is the partial pressure of water vapor in any gas mixture in equilibrium with solid or liquid water.
Ding, ding, ding! You got it!
Yes, I got one right.
Okay, how is water a polar covalent bond?
Polar covalent bonding is a type of chemical bond where a pair of electrons are unequally shared between two atoms.
Yeah, but how is water polar covalent?
Well, the two positive hydrogen atoms bond with the negative oxygen.
What is a calorie, and a joule?
You said calorie twice.
It's okay to cry, as long as you keep working.
One's capitalized and the other is not. So now that we have that straightened out, would you like to tell me the difference between them?
Okay. Well, a calorie, the one that's capitalized, is the dietary calorie that equals 100 physics calories. The physics calorie is the amount of energy that is needed to raise or lower 1 gram of liquid water by 1 centigrade degree.
Okay. I like what I'm hearing. You can continue.
The amount of energy is too small to describe the energy content of food, so the physics kilocalorie is used instead and is simply called a calorie in dietary world. A food calorie is the amount of energy needed to change the temperature of 1 kilogram of liquid water, which is a volume of 1 liter, 1 centigrade degree.
I think you left something very, very important out.
Like what?
That the food calorie is spelled with a capital C. Remember? Yeah.
Fun.
Oh yeah. Well, did you know that the amount needed to change the temperature of 1 pound of liquid water by 1 degree Fahrenheit is called a British thermal unit, or BTU? Food calorie equals about 4 BTUs.
Yes, I knew that.
Well, I bet you didn't know that BTU is the same thing as a metric measuring system, but it's Britain's versions of it.
Oh, I guess I didn't know that. Thanks for informing me.
A joule is the SI unit of work or energy. That is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of the action of the force. It is equivalent to 1/3600th of a watt-hour. Why couldn't I have started with that one?
I never said you had to start with that one.
Oh, now you tell me.
Oh, don't get sassy with me. This is your test, not mine.
Now, what is water's specific heat capacity? Give me both units.
4.179 joules per gram, or 417.9 joules per degree Celsius.
Now, watch this lab.
Surface tension.
Hey kids, it's me, Professor Smartbrain again, and today I will be showing you surface tension and cohesion using a penny and an eyedropper. How many drops do you kids think can fit on the penny? My guess is 16.
Hey kids, now we're going to see how many drops of water can fit on a penny before it overflows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, and it's
This lab shows how water sticks together using cohesion and its magical surface tension abilities. Okay kids, now in this lab we're going to be showing you another lab on surface tension. Alright, what you're going to do is you're going to get 2 cups of water. One of them is just going to have normal water in it, and the other one is going to have an ounce of dishwashing soap in it. And now you're going to take 2 pieces of paper, crumple them up, and you're going to put them in the glasses and watch what happens. Wait, look at that. Okay, get this, hurry, get this.
I'm getting it. I've been filming the whole time.
Hey kids, as you can see, water has a much greater tension than other substances, such as water mixed with dish soap. That's why, in this one, the paper sunk to the bottom, but on this one, it mostly stayed afloat.
Now, What did this show?
Surface tension?
Come on, my boy, what is surface tension?
Well, cohesive forces between molecules cause surface tension. Surface tension helps things with a high density float. The top layer of molecules of a liquid are only bonded with molecules to the sides and bottom, not the top. Therefore, they exhibit stronger forces towards neighboring molecules or beneath the surface.
Now, what is the heat of vaporization?
Well, the heat of vaporization...
Sit down!
The heat of vaporization is 40.65 kilojoules per mole.
What are the boiling and melting points of water?
That's 212 degrees Fahrenheit and 32 degrees Fahrenheit.
What about metric?
That's 100 and for the boiling point and 0 for the melting point.
You forgot your degree. But it's okay, cause you were right.
Now, I'm going to show you another lab.
Alright kids, in this lab I'm going to be showing you the states of matter of water. Alright, so the first state of water is its solid state, which is ice, where the molecules have very little movement. So the second state, the liquid state of H2O, is water. The molecules are much further apart, but they tend to move around a lot more. Last but not least is water's final state, a gas, where the molecules are very far spread apart and they can move very rapidly.
And now it's time for Professor Smartbrain's Fun Fact of the Day.
Did you know that water is the only substance that's less dense in its solid form than it is in its liquid form? That's why ice floats.
Thanks, Professor Smartbrain. What did that show?
It's easy. Water can be a solid, liquid, or a gas.
So can every other element.
What about their parts?
Well, an example of a water being solid is ice. In ice, the molecules are close together and they're compact, so they don't have as much space to move around. In a liquid, like water coming out of the sink, the molecules aren't as compact and have a little bit more room to move around in. In a gaseous state, water molecules are very spaced out and can move around freely.
Second grade. Now, what is the solution process of water?
Solutions are a homogeneous mixture of two or more pure substances. Water combines most things because it's a universal solvent, but there are, again, things that it doesn't bond with, like oil.
What is the difference between electrolytes and non-electrolytes?
Electrolytes exist in solutions as ions. Weak electrolytes have fewer ions and are typically polar covalent compounds. Non-electrolytes do not dissociate. They dissolve in water and molecules as ions and are usually polar covalent substances.
Okay, can I get an example of each, to prepare yourself for this test that you cannot fail?
Okay, I know. Well, ionic compounds, strong acids, strong bases, and strong salts are normally strong electrolytes. Salt is a good example of this. Non-electrolytes are normally polar covalent substances like sugar.
Now, what is the water of hydration?
Easy. Well, we hydrate ourselves with water, so obviously water is hydration.
Go ahead and tell them.
It is the portion of a hydrate that can be removed as water.
Wait a minute. You know what a hydrate is?
It's from 3rd grade!
It's when water is chemically bonded to another element or compound. Hence, why water can be removed.
Okay.
What are desiccants and efflorescents?
Okay, desiccants soak up water from the air, but efflorescence, what is that?
That's for you to tell me, not for me to tell you.
I'll ask Siri then. Hey Siri, what are efflorescents?
Searching. Here is what I found.
See what I tell ya? Siri won't be there for you on the test. See, she doesn't even know what it is.
Okay, well then I'll just Google it and I promise I'll know before the test. Deal?
Not my test, Greg.
Okay. Oh, so it's basically just a substance that loses water to the surrounding air.
Well done. Now sit down.
Oh, geez, sorry.
Why is this not with the calculators?
I'm almost sorry.
What are suspensions?
Suspensions. Okay. A suspension is a heterogeneous mixture in which solute-like particles settle out of a solvent-like phase sometime after their introduction. We apply the word suspension when particles are big enough to eventually settle.
What are colloids?
Colloids. A colloid is a solution that has particles ranging between 1 and 1,000 nanometers in diameter, yet are still able to remain evenly distributed throughout the solution. They are also known as colloidal dispersions because of these substances remain dispersed and do not settle to the bottom of the container.
What is Brownian motion?
Brownian motion is the random motion of particles suspended in a liquid or gas, resulting from the collision with the quick atoms or molecules in the gas or liquid.
What is the Tyndall effect?
The Tyndall effect is the effect of light scattering in colloidal dispersion while showing no light in the solution. The effect is used to determine whether a solution is a true solution or a colloid.
Now, why is water important to the vitality of life?
Okay, this one's easy. So plants take in water. That's vegetation. They have to have water to survive. We have to have water to survive because water is used to transport vital nutrients and substances throughout our bodies as humans.
Mm-hmm.
And in weather, different organisms can survive water in their ecosystems.
Okay.
Good enough. Now we're getting somewhere. How's water unique?
Okay, so let's see. Water is a universal solvent. It is vital to life. It's pretty cool that it can be liquid at room temperature. I mean, yeah.
What about its solid form versus just liquid form?
Oh, it's less dense in its liquid form than solid form. That's unique.
Well, that seems to about wrap it up, but we got one more thing to show you. Another lab.
Not another one.
It's the last one. Hold on. We got this.
Okay, kids, for today's lab, I've learned to talk without moving my lips. We're going to be talking about water and oil. According to Inner Child Fun, water and oil are both made up of molecules that are strongly attached to each other. Water molecules have a positive charge on one end and a negative charge on the other end. Since the opposite ends of the molecule have different charges, it is called a polar molecule. The molecules in the oil are mostly evenly spaced out and therefore do not have charges on the opposite ends of the molecule. These are called nonpolar molecules. Since the water and the oil molecules are different types, they do not mix. When the dishwashing liquid is added, it causes the bonds between the molecules to change and allows the liquids to mix. Thanks for listening, kids. I hope you enjoyed today's lesson. This is Professor Smartbrain signing off.
Is that it?
Think we're done?
Yeah, I think you're ready.
We're done? I'm done! I'm done!
No!
I'm done!
No!
I'm done!
No! Sit down! Get back here! Should I knock him out?
Here, let a real person do this. That's how you do it.
So we want to thank you people for watching our video. After we're done editing, it's probably like 20 minutes by now.
Well, guys, I don't think this is the water project.
What?
The script right there, it says hotter project.
With an H?
talking about?
With an H, look.
Hotter?
Well,
What? I am dyslexic, so I mean...
Colin.
Wait a minute. Wait, I have an idea.
What's your idea? Okay. Okay, that's good.
Coming in unannounced, drag my nails on the tile. I just follow your sin. You can just follow my smile. All of your flaws are aligned with this mood of mine. Caught in me